This is the start of Chapter P, Section 1. It's all about real numbers and how to represent sets of real numbers. When you're taking notes, you can pause the video as you go to write down anything you need to write down so that you're ready for the section and the activity and assignment tomorrow in class. So the set of real numbers is broken into two sections or two sets. Rational numbers, you'll see that on the left, and irrational numbers, you'll see that on the right. Rational numbers right here are any set of numbers that can be written as fractions. Okay, written as for A over B, anything that can be written as a fraction. So that would include numbers like 1/2, because that's obviously a fraction. Even numbers like 5, because that could be written as a fraction as long as you put a 1 underneath of it. And numbers like 0.2, because 0.2 can be written as 1/5. Okay, so all those are rational numbers. Numbers that are not rational or that are irrational numbers are any numbers that can be written, that can't be written as fractions. So some examples here are square root of 2, square root of 3, any like square root, not square root of 4 though, because that's actually 2. Pi is an example here. The number e, if you look on your calculator, there's an e button, and that can be approximated to 2.71. Okay, so all those are irrational numbers. So then we have, let's go back to the rational numbers. So if you look below rational numbers, you'd see integers, and integers are listed. So those are all the negative and positive whole numbers that you're used to seeing. Underneath integers are the set of whole numbers, which are basically integers but not the negative ones. So we've got 0, 1, 2, 3, and so on. And then below that is another subset, which are called natural numbers, and they're whole numbers but without the 0. So those are natural numbers. So all these are just different sets of numbers. Notice imaginary numbers or complex numbers are not here. That's a whole other set. Okay, so these are only real numbers. All right, so since we're talking about sets of numbers, we have to talk about different ways to represent those sets of numbers. So one way are inequalities, and those use the inequality symbols. Less than, greater than, less than or equal to, greater than or equal to. We can also write sets of numbers using interval notation, and that uses parentheses and brackets. And so we have our example here, which we've already practiced this year. We can also graph on a number line, but you're used to graphing using open and closed circles. We're actually going to instead use parentheses and brackets on here. So I'll just give you an example, like if I have 1, 2, and 3. You're used to using an open circle or a closed circle and then shading one way or the other, or shading wherever your sets of numbers are. So instead, this same set, so same one that's listed here, instead of using an open circle, we're going to use a parenthesis at 2, and still we're going to shade to the right. So these would be numbers that are greater than 2. If it was greater than or equal to, so if this was closed in, then instead of using this parenthesis, we use a bracket. Okay, so that's the only change of how we're going to graph. And then the last way that we can represent numbers is using a set of numbers is actually writing it out in words. We can use words like greater than, less than, between, including, excluding, and there's lots of different ways sets can be written in words. Alright, so let's try a couple. So we have x is less than 3, and we want to represent it in different ways. So if we were going to represent using a number line, so we're looking for the numbers that are less than 3. So maybe we'd use 2, 3, and 4 here on our number line. And numbers that are less than are to the left, and it's not included, so we're going to use a parenthesis. And we're going to shade to the left. Okay, so that represents the numbers that are less than 3. If we're going to use interval notation, so the smallest number in this set is negative infinity. And it goes all the way to 3, but 3 is not included, so we're going to use a parenthesis. And then we can write it out in words. Alright, so written out in words, we have the set of real numbers that are less than 3. Alright, so let's go ahead and look at example B. So we have 2 less than or equal to x less than 5. So we're going to draw a number line. And we can draw all the numbers if you just want to put 2 and 5 for now, just to save us some time. Alright, so we've got 2 is included. So we're going to use a bracket. 5 is not included, so a parenthesis, and then we're going to shade between. Okay, so again, just like you did before, just instead of using open and closed circles, you're using parentheses and brackets. So then back to interval notation. So we've got between 2 and 5, so bracket 2 all the way to the number 5, but not including 5, so parenthesis. And lastly, in words, we can say that it's all real numbers between 2 and 5, including 2, but not 5. And remember, there's lots of ways you can write these as long as you are saying if something's included or not, saying if it's supposed to be less than, greater than, bigger, between, any of those words. Alright, now when we have all of these intervals or an interval notation, we have different types. So if you have an interval that has infinity or negative infinity, it's called unbounded, and ones that don't are called bounded. If we have an interval that uses brackets for the numbers that you have, remember, infinity and negative infinity always use a parenthesis, but if the numbers that you have are all brackets, it's closed. If the numbers you have have parentheses, it's called open. And then if you have one that's got a bracket and one with a parenthesis, so both, then it's half open. But notice you can't have an infinity in this one, so it has to only be numbers. So if we are going to state the interval type of examples A and B down below, A would be unbounded and open. Okay, unbounded because it does have infinity in it, and open because the number that it has is a parenthesis. And when you go to example B, it would be bounded and closed. Okay, bounded because it does not have infinity, and closed because both of the numbers have brackets. Lastly, we can write our numbers not in just a standard or sometimes called decimal form, but we can write it in scientific notation. So if we think about scientific notation like this first one that is supposed to be 6.3 times 10 to the 4th power, we want to look at the very first number in scientific notation. It has to be between the numbers 1 and 10. It can be 1, so we're going to use a bracket, but it can't be 10, so we're going to use a parenthesis. So that's the interval notation for the first number in scientific notation. Alright, so we've got 6.3 times 10 to the 4th written in scientific notation. Times 10 to the 4th, that's a very large number. So that means 6.3 is going to get bigger. So it ends up becoming, if we move the decimal place 4 times to the right, so just imagine moving it 4 times to the right, becomes 63,000. Okay, and again, the decimal used to be here, and it went 1, 2, 3, 4 places to the right. So that's why, again, it is 63,000. Alright, so you might, if it had a negative exponent, then the decimal would have moved 4 places to the left, and it would have become a very small number. Alright, so in this one we have 4.57 times 10 to the 7th. And then we have 5 times 5.3 times 10 to the negative 3rd. So you could write it out in standard notation and then multiply the two, or we can just multiply the 4.5 and the 5.3, and if you do that you get 23.85 times 10 to the, and now we've got 10 to the 7th times 10 to the negative 3rd, and they have the same base, so you can just add the exponent to get to the 4th power. But we're not allowed to leave our answer like that because the first number is not between 1 and 10. So we're going to move the decimal place one time to get 2.385 times 10 to the. So our number is going to change by 1, and the 23.85, since that was too big, then the exponent needs to get 1 bigger, so times 10 to the 5th. So this would be the product of those two, and written in scientific notation.